Yes, good morning students. Welcome to my channel. Today I am going to discussing about the topic is tangent and normal to a curve. Very important concept from the mains and advanced point of view. Recently from the mains, so we got the 3 to 4 questions from the continuous days of mains exam. Okay, let us see first of all what is a tangent and what is a normal to a curve. Okay, yes. So let us take a curve, right? Y equals to f of x is a curve. A line which intersects this curve at two distinct points. P and Q. Now I can say this line is secant. A line which intersects the curve at two distinct points, then it is called secant of that curve. Now here is the point Q is moving. The point Q is moving along the curve. Okay, now I can get the lines are like this. Yes, I can get the lines are like this. Finally I can get particularly the line is like this. Right? So when the point Q is moving along the curve and reaches to the point P, so now I can write the limiting position. So the limiting position of secant, to that curve becomes the tangent to the curve. Can I write like this? The limiting position. So when the point Q reaches to P, in that case the limiting position of this secant line becomes tangent. Right? Now I can define that. What is the meaning of a tangent? A tangent is a line which touches at only one point the curve. Then in that case this is called tangent. Okay, and particularly the point P is called the point of contact. Okay, so that is about the definition of a tangent. Okay, then what about the normal? Normal means it is a line which is perpendicular to the tangent. What is that? Which is perpendicular to the tangent at the point of contact. Which is perpendicular to the tangent. So this is the point of contact, this is the tangent, and exactly at this case at the point of contact which is perpendicular to the tangent, which is called normal to the curve. Okay, so that is we are going to find this one. That is about the tangent and normal to the curve. Okay, that is the definition of that one. Okay, let us see how to find the slope of the tangent, how to find the slope of normal, how to get that equation of the tangent to the curve, equation of the normal to the curve. Let us see the students. Yes, let us see the geometrical interpretation of derivatives. Okay, let P be any point at the curve y equals to f of x. Then the slope of the tangent to the curve at that particular point is, how I am going to define it, is dy by dx, derivative of that function with respect to x at that particular point P, which is f dash of x at the point P. How it is? Let us see. So here I am going to define that geometrical interpretation of the derivative. I mean we are going to find the slope of a tangent at the particular point P. How it is? So let us see. I am going to take a tangent, curve. So this is y equals to f of x, right? So first of all, it is a secant P Q which intersects at P and Q, right? Okay. So let us say P is x comma y. The point P is x comma y. This is the x coordinate and this is the y coordinate. Okay, and the point Q is, let us take the distance between them. This is the x plus h. So its corresponding values are f of x and f of x plus h. Corresponding values are. Okay. Now when the secant becomes a tangent, just now I explained. Okay, the point Q is moving along the curve. When it reaches to the point P, then the secant becomes a tangent. Now that means I can define like this. The distance between them is h. That is, when the point Q reaches to the point P, Okay, that means the distance between these two becomes almost 0. Then I can write like this: limit h tends to 0, right? Limit h tends to 0, right? That means when it is happening, the difference in y coordinates, that is f of x plus h minus f of x, right? The difference in y coordinates with respect to difference in x coordinate, the by x plus h minus x, right? In that case, in this case, what is happening? The secant becomes a tangent. Am I right? The secant becomes a tangent. Okay. So actually, what is this is the difference in y coordinates to difference in x coordinates is nothing but the slope of a line. Particularly, what is this line is the? This line is the tangent. Am I right? That means I can say this is called the slope of the tangent. Okay, the slope of the tangent. And already we know this one. What is this? Limit h tends to 0. F of x plus h minus f of x by h is nothing but f dash of x. Am I right or not? F dash of x, which is called the derivative of the function. Okay. Yes, finally I am going to define it is the slope of the tangent. The slope of the tangent at the point P is nothing but the derivative of the function dy by dx. So the same thing is I can write dy by dx, the derivative of the curve where it is at that particular point P. At the point P. Like this, I am going to defining the slope of the tangent. Yes, finally, what is the slope of the tangent to the curve means simply what you are going to find. Derivative of the function with respect to x. Of course, with respect to x. Right or not? At the point P, which is called slope of the tangent. Slope of the normal is minus dx by dy. At the point P, I think you know this one. The product of the slope should be minus 1. Right? Yes, based on this, we'll get that some problems. Okay, yes. Then how can you get the equation of the tangent? Of course, you know this one. When the point P is given, we are going to get that slope of a tangent, and obviously by using the point slope form, we will get the equation of the tangent by using our traditional formula y minus y1 equals to m into x minus x1. We will get the equation of the tangent. Of course, if you get the equation of the tangent, obviously its perpendicular line is the equation of the normal. Okay, let us discuss some problems. Come on, students. Yes, so let us discuss some problems. So the first one is find the equation of the tangent to the curve x by a raised to the n plus y by b raised to the n is equals to 2 at the point a comma b. And one more problem same like this, equation of the tangent to the curve y equals to b into e power minus x by a at the point, here the point is not given, where the curve meets the y axis. Yes, let us see. So coming to the first problem, I am going to take that first one, x by a whole power n, the given curve, plus this is y by b whole power n equals to 2. Now we are going to find the equation of the tangent. First of all, I am going to finding the slope of the tangent at that particular point. Then I can get the equation. Yes, already we discussed that. What is the meaning of a slope of a tangent to the curve? Is nothing but simply derivative of that given curve at that particular point. Yes, then come on, derivative with respect to x. So I am going to differentiate it. So this is 1 by a power n constant x power n derivative n into x power n minus 1 plus this is 1 by b power n constant y power n derivative n into y power n minus 1 into dy by dx is equals to 0. Constant derivative is 0. Now at the point P, what is the point P? A comma B. Substitute the value in place of x is a, y is b. So this is 1 by a power n into this is a power n minus 1 in place of x coordinate is a plus 1 by b power n, okay, and this is n into y value is b power n minus 1 into dy by dx is equals to 0. Come on, simplify the values. Here a raised to the power n minus 1 times, here a is n times, b raised to the power of n minus 1 times, and b is n times. So simply that, so I can get here is n by a and here is n by b, okay, into dy by dx is equals to 0. So which is dy by dx equals to, this term is minus n by a, okay, and this term is minus b by n, so which is minus b by a, so which is the slope of the tangent. right? M equals to minus b by a, slope of tangent. Okay, now what is the equation of the tangent at the point a comma b is, this is y minus y1, y1 is b, y minus y1 equals to slope minus b by a into x minus a. Okay, so by simplifying this one, this is ay minus ab equals to minus bx plus ab. Okay, yes, so totally by simplifying this one, we'll get this is bx plus ay is equals to 2ab. So finally simplifying, I can get x by a plus y by b equals to 2, which is the equation of the tangent at the particular point. Come on, see the process, students. Come on, make a note. Yes, coming to that next problem, find the equation of the tangent to the curve at the point where it meets the y-axis. Where it meets the y-axis. So then what is the point? When it meets the y-axis, x coordinate is 0. When x coordinate is 0, y coordinate becomes p. Now at the point p, I am going to find the equation of the tangent. Of course, as usually, the slope of the tangent. Okay. So the slope of the tangent, which is nothing but derivative of the given curve at the point p, 0 comma b. So come on, take the derivative. Dy by dx, the b is a constant, e power minus x by a derivative, e power minus x by a into minus 1 by a, x quotient is minus 1 by a. Yes, at the point p, the point p is 0 comma b. In place of x, please substitute 0. In place of y, b. So there is no y term, simply which is minus b by a. So this becomes total, it is 1. So which is the slope of the tangent? Okay, then I can get the equation of tangent. Equation of the tangent at the point p, 0 comma b is y minus y1 equals to slope is minus b by a into x minus x1. x1 is 0. So this is ay minus ab is equals to minus bx. So simply I can write bx plus ay equals to ab. This is the equation of the tangent to the given curve. Okay, students, make it out. So now the next topic is angle between the two curves. Angle between the two curves. So okay. So what is the definition of an angle between the two curves? The two curves, from these three cases, the two curves are intersecting at the point P. Okay, in this case they are intersecting, they are touch each other at the point P. So now what I am going to define in this, angle between the two curves is nothing but angle between the tangents. Angle between the tangents at that point of intersection. Okay, so whenever we are going to finding the angle between the two curves is nothing but angle between the tangents where they are intersecting the curves. Okay, yes, coming to the first case. So these two curves are intersecting at the point P. Yes, at that point P, I am going to draw the two tangents for the two curves. Then this is the angle between the tangents to that, theta is the angle between the tangents. This is nothing but angle between the curves. So one angle is theta, of course it is obtuse angle, and one more angle is the 180 minus theta. Generally angle between the two tangents means we can take that acute angle. Of course, if they are mentioned particularly, then only we are going to find that one more angle, I mean obtuse angle. Okay, yes, coming to this one. So anyway, finally angle between the two curves is nothing but angle between the tangents at that point of intersection. So angle between the tangents means we are going to finding the slope of that tangent to the first curve. Okay, so which is by derivating the first curve, right? So I can take that the slope is m1, right? Similarly, slope of the second tangent is m2 and angle between them is theta. Now by using this formula, I am going to finding this one, tan theta equals to m1 minus m2 by 1 plus m1 into m2, where m1 into m2 is not equals to minus 1. So if it is acute angle, please better to take in the modulus. Like this, we are going to finding the angle between the tangents. Okay, suppose that in second case. So here, particularly clearly observing this one. So the two curves are touch each other like this. Okay, and if you are going to draw the tangents are perpendicular, then I can say angle between the tangents is 90 degrees. Angle between the tangents is 90 degrees. Then I can say the two curves are cut each other orthogonally. Yes, what do you say? The two curves are cut each other orthogonally when the angle between the tangents is 90 degrees. And coming to the third case, yes, here observe this one. So there is only one tangent. Okay, that means for the first curve, finding the slope of the tangent, for the second curve, finding the slope of the tangent, we are going to get the equal. If m1 is equals to m2, slope of the tangent to the first curve, slope of the tangent to the second curve. If m1 is equals to m2, that means I can say the two curves are touch each other at the point P. That means for both the curves, they have a common tangent. Okay, like this, in these different cases, we are going to finding the angle between the curves. Okay, students, come on, make a note in these different conditions. Yes, let us see. So one more concept, applications of derivative for finding the shortest distance between the two curves. Very important, shortest distance between the two curves. Okay, let us, I am going to explaining that by taking one problem. Find the shortest distance between the line y equals to x minus 2 and the curve y equals to x square plus 3x plus 2. What do you say it is? Parabola. So the distance between the line, shortest distance between the line to the parabola. Okay. So I am going to draw the graph. So now we are going to find the shortest distance. So this is y is equals to x minus 2. So inclination is 1, which intersects the y-axis at 0, minus 2. Y-intercept is minus 2. So this is the line y equals to x minus 2. Okay. And what about this parabola? Y is equals to x square plus 3x plus 2. Okay. When x is 0, y is 2. When x is 0, y is 2. I mean, it intersect like this. Okay. X square quotient 1 positive, which is upward parabola. And when y is 0, I mean, where it intersect the x-axis, x square plus 3x plus 2. So which is minus 2 and minus 1. So which we intersect like this. Okay. Yes, now I am going to find the shortest distance between these two. How to find the shortest distance between this line and this curve? Yes, so this is possible only when they have a common normal for between these two. Okay, this is the shortest distance. I can say at the same time, this is the common normal for both line and for the curve. If it exists, then only it is possible. Or else I can find one more way. So that is the, here I am going to finding the a tangent which is parallel to that line y is equals to x minus 2. Am I right? So here I am going to finding the a tangent which is parallel to the line y equals to x minus 2. Okay. Yes, clearly the slope of the line is 1, y equals to x minus 2. Here also the slope of the tangent to the curve which is parallel to this line also must be 1. That means for this curve, the slope of the curve mean the slope of the tangent, okay, at the point P, let us suppose at the point P, okay, is 1. Why? Because this tangent is parallel to y is equals to x minus 2. Yes, so come on. First of all, what is the slope of this curve? Is nothing but the derivative of that function, which is 2x1 plus p. Of course, p, then let us take the point x1, y1. Okay, so 2x1 plus 3, 2x1 plus 3 equals to 1. So which is x1 is equals to minus 1. So x coordinate is minus 1. Yes, come on. If x1 is equals to minus 1, then what is y1 value? It is 1 minus 3 minus 2 plus 2, 0. So y coordinate is 0. Then I got the point P. What is the point P? Is minus 1 comma 0. Yes, I think now we got that. Now what is the shortest distance between the line to the curve? Is nothing but the distance between the two parallel lines, or else the distance of the point P where it touches where the tangent touches the curve. I mean where the tangent is parallel to the line. Okay, next. So this is the distance, shortest distance. I mean the distance of the point P, which is minus 1 comma 0 to the line x minus y plus 2 equals to 0. That is the shortest distance is PQ. Yes, finally I got the shortest distance. That is the distance of the point P minus 1 comma 0 to the line. So which is modulus of ax1, which is minus 1, okay, plus by1, which is 0, and constant minus 2 by root of a square plus b square, which is 3 by root 2. Right? Very important concept. Shortest distance between the curve and a line, or shortest distance between the two curves which are not intersecting. That is the main thing, which are not intersecting. Okay students, come on, make a note. Yes. So let us discuss some problems. So up to now what we discussed is that tangent, normals, angle between the two curves, like this. So let us take some problem. If the normal to the curve y equals to f of x at the point 3 comma 4 makes an angle 3 pi by 4. Yes, normal line. The normal line makes an angle 3 pi by 4 with x-axis. Then what is f dash of 3? Very simple problem. Normal line making an angle at the point 3 by 4 makes an angle 3 pi by 4. Can you say this one? What is the slope of the normal? What is the slope of the normal? I mean, its inclination is given. Its inclination is 3 pi by 4. So slope of a normal is, so tan 3 pi by 4, which is minus 1. Okay. Yes, so let us see what they are asking. F dash of 3. What is the meaning of f dash? Derivative of the function. Okay, that means clearly the slope of the tangent. Indirectly they are asking the slope of the tangent at the point 3. Yes, at this same point only they are asking. So the question is, so what is the slope of the tangent? Slope of the normal is minus 1. Simply slope of the tangent is plus 1. That's it. This is the problem. Very simple. Okay. Yes. Coming to the next one. So the normal to the curve x square plus 2xy minus 3y square equals to 0. We are going to draw the normal to the curve at the point 1 comma 1. And they ask for the question is where the normal meets and again the curve. Okay. Yet which of the following points? They are asking the normal and again meets the curve in which quadrant? That will be the question, which is from JE 2015. Okay, let us see. Yeah, it is nothing but a pair of straight lines. Yes, you can split this one. I can write like this. This is x minus y into x plus 3y equals to 0. Right? Yes, now take that diagram. Y equals to x. Y equals to x. So this is the first line. Y equals to x, which is passing through origin. The first line, and second line is y equals to minus 1 by 3x. It is also passing, the slope is negative. Y equals to minus 1 by 3 into x. Okay, so there is no chance to get 1 comma 1 on the second line. Okay, now we are going to draw the normal to the curve at the point 1 comma. Yes, already 1 comma 1, the point is 1 comma 1 on this line is there. Now I am going to draw the normal to the line. This is the normal to the line, right? So this is the normal. So yes, this normal and again meets the curve. Of course, meets the pair of lines. Of those pair of lines, one of the line, and again it meets at this point. They ask that in which quadrant the normal and again meets this one. So which meets in Q4. Simply they ask like this. Okay, students, come on, make a note. We'll discuss some more problems. Let us discuss one more problem, which is 5th September 2020 evening shift paper. Okay, yes. Which of the following point lies on the tangent to the curve at the point 1 comma 0? So here they have given that 4 points. So which of the following point lies on the tangent to the curve at the point 1 comma 0? First of all, there is no tangent. So first we should find the tangent at the point 1 comma 0. Then after we should check these options. Okay, come on. So slope of the tangent, first we should find this one. Come on, for this given curve is differentiating, I can get the slope of the tangent at the point 1 comma 0. So it is x power 4 separating e power y derivative e power y into y dash plus e power y separating x power 4 derivative 4x cube plus 2 into, okay, root of 1 plus 1, 1 by 2 root of y plus 1 into y dash equals to right side's derivative is 0. Okay, get cancelled. So at the point 1 comma 0, so in place of x, substitute the x coordinate and y coordinate is 0. So it is x power 4, x value 1, 1 into e power 0, right, e power 0 is 1 with y dash plus e power 0 is 1 with 4 into x cube is, it is 4 plus, so y value is 0, it is value 1 with y dash equals to 0, right, which is 2y dash plus 4 is equals to 0, y dash equals to minus 2. I mean, I can get the slope of the tangent is minus. Equation of tangent. Equation of tangent at the point P 1 comma 0 is, okay, so it is y minus y1 equals to m, which is the slope of the tangent minus 2 into x minus 1. This is y equals to minus 2x plus 2, okay, so which is 2x plus y minus 2 equals to 0, 2x plus y minus 2 equals to 0. Come on, check the options, which of the following point lies on this one. So 2, 2, 2, 2, okay, not satisfying, minus 2, 4, minus 2, 4, not satisfying. Okay, coming to this one, minus 2 comma 6, minus 4 plus 6, so 2 minus 2 is 0. Yes, that's our option. Minus 2 comma 6 is satisfying the given tangent. Okay, students, come on, make a note. Yeah, so one more problem, which is 2nd September 2020, morning shift. If the tangent to this curve at the point A comma B is parallel to the line joining of the 2 points, then which of the following condition will be correct? Okay, so here clearly the tangent is parallel to the line joining of these two. Okay, I think no need to find the equation of the tangents. So two lines are parallel, simply we are going to equating the slopes. I mean, slope of the tangent is equals to slope of these 2 points PQ. Am I right? So first of all, what is the slope of PQ? Slope of PQ, this is y2 minus 2 minus 3 by 2, which is 1 by 2 by 1 by 2, which is 1. Slope of this line PQ is 1, and of course the slope of the tangent also obviously is equals to 1. Why? Because this is parallel. So I can say the slope of the tangent, so at the given point of A comma B is also equals to 1. Come on, what is the slope of the tangent? Is nothing but dy by dx to this curve. Okay, so which is dy by dx. Yes, come on, what is dy by dx? 1 plus cos y. Yes, at that particular point, at the point A comma B, this is 1 plus cos y coordinate is B is equals to, it is already given, which is 1. So that means cos B equals to 0. So cos value 0, cos angle 0, then I can say sin angle, can I take plus or minus 1? Cos B value 0, sin B value plus or minus 1. Yes. Now coming to this curve, the point A comma B lies on this curve. Okay. Now can I write like this, which is B equals to A plus sin B, right? That means B minus A is equals to sin B. So already sin B value plus or minus 1, yes, then I can take the modulus both sides. So modulus of B minus A equals to 1. Yes, it is very clearly the third option. Yes, very simple problem from the tangent and the normal concepts. Come on students, make a note. Yes, one more problem, so which is from 3rd September 2020, evening shift. Let us see. So if the tangent to the curve y equals to e power x at the point C comma e power c, yes, and normal to this curve y square is equals to 4x at the point 1 comma 1 intersects at the same point which are on x-axis. So where the tangent to the curve which meets on x-axis, at the same time where the normal to this curve at 1 comma 1 meets at x-axis, both the points are same. In that process, what is the value of c? That's what they are asking. Okay, come on, first of all find out the equation of the tangent where it meets the x-axis. So first of all, the curve, first curve y equals to e power x. So its derivative dy by dx is e power x. So at that particular point c comma e power c, which is e power x coordinate is c. Okay, this is the slope of the tangent. Now what is the equation of tangent? Equation of the tangent at this particular point, let us take it as p. Equation of the tangent at p, which is y minus y1 equals to m value e power c into x minus x1 c. Yes, and where it meets the x-axis. So here I am going to write which meets the x-axis. Where in line meets x-axis, that means its y coordinate is 0. So in that case y equals to 0. So this is minus e power c equals to e power c into x minus c, get cancelled. Then x is equals to, okay, then x is equals to c minus 1. So this is the equation of the tangent at the point P. Okay, yes. No, this is the x coordinate is c minus 1. So that means the point is c minus 1 comma 0. Right? Let us take this point is m. Okay, coming to the second curve, which is y square is equals to 4x. Yes, so differentiating, which is 2y into y dash is equals to 4. So y dash equals to 2 by y at that particular point q. So at q, which is 1 comma 1, which is 2. Yes, for this one, what is the equation of a tangent? Equation of tangent at q 1 comma 1 is, so y minus 1 equals to slope is 2 into x minus 1. So it is y minus 1 is equals to 2x minus 2. Simply I can write 2x minus y minus 1 equals to 0. Okay, yes, and where it meets the x-axis, its y coordinate is 0. So x coordinate is 1 by 2, y coordinate is 0. Right? So here they have given clearly same point. So come on, compare the x coordinates. So it is a c minus 1 is 1 by 2 and c is equals to 3 by 2. That is the very simple problem. So from that mains 2020 question. Yes, one more thing I want to say the students. So if you want to ask any specified particular topic, please put it a comment in the comment box. Then I will try to explain that particular topic. Okay, and one of my student asked about that maximum minimum. Okay, and after that my video is about the maximum minimum. Okay, yes, come on, please students make a note.